Welcome back, grade 11s and 12s. We want to discuss question 5 in the grade 11 November 2020 exam. This question is on electric circuits. So they say, study the circuit diagram below. Each cell in the battery has an EMF of 3 volts. So this one cell has an EMF of 3 volts. That one's EMF is 3 volts. This one's EMF is 3 volts. And the fourth one's EMF is 3 volts. The ammeter has a negligible resistance because it's not allowed to add to the resistance in the circuit and in such a way change the current that flows through the resistors. Question 5.1 asks us what the reading on the voltmeter is. This is the voltmeter. Now, to notice is that we have the ammeter reading the total current because it's connected in series to the battery. Then the 3 ohm resistor is connected in series to the 2 ohm resistor if the switch is open. There will be no current flowing through here, no current. Because the voltmeter is connected parallel to resistor X, and there is no current flowing through there, voltmeter reads potential difference. And we could look at it in 2 ways. The potential difference is, by definition, the work done on moving charge from one point to another in a circuit. So if there's no charge moving through, there is no work done. So then the reading on this voltmeter would be 0 volts. We could look at it in another way by using Ohm's law, where V is directly proportional to I, and it is I times R. Let me write it that way. V is I times R. If no current is flowing, then the potential difference would be 0. Right, then they say this switch is now closed. If the switch is now closed, there will be current flowing through the X ohm resistor, and the current would split at this point, the total current. The reading on the ammeter, which is the total current, is now 2.5 amperes. Calculate the total resistance in the circuit. Number 5.2. So for question 5.2, we need the total resistance in the circuit. Now, more than one path to take. If we've got the total voltage, we could divide it by the total current. So we need to calculate the total resistance. And that is in 5.2. The total resistance can be calculated by using Ohm's law if we've got the total potential difference and the total current. The total potential difference would be the 3 volts times 4, which is 12 volts. and the total current is given as 2.5 amperes. That is the easiest way to get the total resistance of 4.8 ohms. 5.2 is done. Question 5.3 asks for the reading on the voltmeter. Now, the reading on the voltmeter would be the reading on the across the parallel resistors now as well. It's not just the reading across X ohms, because 3 ohms and X ohms are connected parallel. The same energy is used to push the current through them. Now, I don't know what X ohm is, but I know what the current is through the 2 ohm resistor, so I can calculate this potential difference across the 2 ohm resistor. I know that series connected resistors are potential dividers. Now, 3 and X, they're parallel, but they're in series to the 2 ohm resistors. So the total voltage would be the voltage across the parallel combination plus the voltage across the 2 ohm resistor. So the 2 ohm resistor's voltage is I total times R2. So that is 2.5 times 2, which gives us 5 volts. So the total voltage is 12. The parallel voltage would be 7. Done. Next question is to calculate the power dissipated through the X ohm resistor. Power dissipated through the X ohm resistor, 5.4. If I had the voltage across that, and the resistance, I could use this equation. Do we have the voltage? No. Can we get the voltage? Yes, but I think there's an easier way to get to this answer, and that is the power is I squared R. Oh, no, no, no. How would we do this now? Could we calculate R? Oh my, the other equation is P is VI. Now, for the X ohm resistor, I've got the voltage. It is 7. How can we get the current? Can we get the current through the 3 ohm resistor? Yes, because we've got the voltage and the parallel voltage and the resistance. So current is parallel voltage, which is 7 divided by 3, which is 2.33 amperes. The total current splits. So the current through the X and the current through the 3 ohm resistor would give us current through X. So the total current. So 2.5 is the current through X plus the 2.33 amperes. And that takes us to current in X is 2.5 minus 2.33, that is 0.17 ampere. We've got enough information to calculate power through X. 0.17 times 7 is 1.19 watts. Thank you for watching this discussion. Have a great day.